Now in this lecture, we are going to learn about the moment, how to calculate the moment, and moment is the most important topic in our subject engineering mechanics. Okay. Now let's consider one example here in which here you can see that a force F is acting at the point C on a beam. Okay. This is a horizontal object, rectangular object. We called it as a beam. If it is in vertical position like this, then we call it as column. Okay, so this is the difference between beam and column. Okay, if it is vertical, then we call it as a column. If it is horizontal, then we call it as a beam. Okay, now what you have to find here, the moment at point A, then moment at point B, then moment at point C. These three things you have to find. Okay, now how to find these three things? By using which concept? By the definition of moment. What is the definition of moment? Force multiplied by the perpendicular distance. Remember this thing. The distance is perpendicular. Distance is perpendicular. So this must be the perpendicular. Your distance must be perpendicular to the line of action of force. To the line of action of force. Okay. Now, this F multiplied by the R, that will be the moment by the force F about point A. At which point you are going to calculate the moment, that is most important. Only moment is not important. Moment at which point it is important, right? One simple example I can tell you, that in your home, in your house, you are having a door. Okay. And the door, you apply the force on the handrails or on the handle, then that force will cause the moment at the hinge. Okay. Suppose that this is your door. And you apply the force at this point. Now what will happen, that this door will get a moment from this location to this location. Okay, suppose that this is point A and this is point B. Okay, now this is just a common example I am telling you, that this can be a very common example, that a force is applied here on the door and this door is get displaced from the point A to point B. Okay, with certain angle theta. Let's suppose that certain angle is there. Okay, now what will be the exact moment? That depends upon the radius, right? the door is rotating in a circular manner, so that circle will have a radius. Okay, so therefore this force multiplied by the radius, that will be the moment. But the moment will be at which point? Moment will be at this point O, at the point O here. Here the moment will act. Okay, whatever the force you are applying at the point A, that will displace the door from the point A to point B, but the action will be here at the point O. Means the moment, action of the moment will be at point O. At point O means what? At the hinge. The moment will act at the point hinge, that is at its center of the circle. Okay, so in the similar manner, here also you will get the same thing. Here also you will get the same thing, that a force is applied. This force is applied at the point A, at the point C in the left diagram, and you are calculating its effect at the point A. You are calculating the moment at point A. So therefore, you have to consider only that distance from the line of action of the force about that particular point, and that distance must be perpendicular. Okay, so therefore F multiplied by the distance R, that will be the moment at the point A. Okay, now in the next case, moment at the point B will be F multiplied by R by 2, because that is the distance from the point B to point C. Okay, from the point B to point C, the distance is R by 2. So therefore, F multiplied by R by 2 will be the moment acting at the point B. Okay, now after that, you have to find out the moment by the force F at the point C. Okay, now at the point C, your distance from this point C to the line of action of force is 0. So therefore, F multiplied by 0, and that will give you the answer 0. Okay, and what will be the unit in each case? Unit will be Newton meter. Here also unit will be Newton meter. Here also unit will be Newton meter. In all three cases, the unit will be same. Only the difference is that the values are different, because the moment changes as the distance changes. Okay, now remember one thing, that your moment is directly proportional to the distance. When you increase the distance, moment also increases. In case of the door also, we have seen that as you increase this distance, your action at the hinge increases, right? This is your door, and you increase this distance. Okay, you are applying the force here, you increase this distance here, the moment acting at this hinge will also increases. Okay, so moment has a natural significance, you remember this thing. Okay, now after this we are going to cover some of the numericals based on the moment, okay, so that's why you should be with your notebook and calci to solve the numericals along with. Okay, Now, there are various types of numericals based on the moment. Okay, so the one of the type is to find the support reaction. Okay, so type 1 can be to find the support reactions. Okay, now we are covering the basic concepts of engineering mechanics. Okay, you should not compare these things with your syllabus. Okay, some things are the very basic concepts, and that concepts are used in all the units, not only for the limited to first unit. Now there are many concepts which might be useful in unit 5, unit 6, unit 4, unit 3. Okay, so the concepts are used all over in all units. Okay, so you should not compare whatever we are covering in this lecture. Don't compare it with your syllabus of only unit 1, though we have written here unit 1, but the concept is used in all units. Okay, so therefore this concept is also used in the equilibrium. Okay, and equilibrium belongs to the statics. Okay, so therefore to find the support reaction, now support reaction means what? Let's take an example again for the beam. Okay, now suppose that this beam is here. Okay, and this beam is resting on the support, so that's why this beam may be called it as a simply supported beam. This beam might be called it as a simply supported beam because this beam is resting over a certain support, so that's why we call this beam as simply supported beam. Okay, now you can see the green color supports are there for this beam. Okay, now in exam you might get such beam and you might get certain forces imposed over this beam, such as this force is a point load. We called it as a point load imposed at the center. Okay, now the distances are also given. Okay, one more force, let's consider one more force. And for our practice purpose, we will add one more force at this point. Okay, now let's assume that this point is A, this point is B, this one is C, and the last one is D. Okay, and also consider certain distances. Now we have the forces and its distances. We have also its magnitudes. Okay, now I will also tell you about the equilibrium conditions. Okay, what is the equilibrium conditions? Now these are the three equilibrium conditions. First one is summation of fx is equal to 0. Second one is summation of fy is equal to 0. And third one is summation of moment at any point is equal to 0. So these are the three equilibrium conditions which are very important. Okay. Now what is the equilibrium conditions? If certain body, certain object which are having certain system of forces satisfies these three conditions, this means that the body is in equilibrium condition. This means that the body is in equilibrium condition. Okay. Now what is the meaning of first condition? Summation of fx is equal to 0. Summation of component of all forces acting in x direction, that summation is 0, then the body is in equilibrium condition. This is first condition. Summation of fy is equal to 0 means summation of forces acting in y component or summation of forces splitted in y component, their summation is 0, then the body is in equilibrium. This is the second condition. And third condition is summation of the all moment acting on the body is 0. If certain body object satisfies these three conditions, 1, 2, and 3, then only we called that body, then only we can call that body in a equilibrium condition. Equilibrium means stable. Remember this thing. What is the meaning of equilibrium? Equilibrium means it represents equilibrium means stability. Remember this thing. Equilibrium means stability. Okay. So the body, we may call it that body is in, or we confirmly can call it in equilibrium if it satisfy these three conditions. In simple language, how we can explain this? We have also studied the sign convention. We have studied the sign convention that this is positive, this is negative, this one is positive y-axis, and this is negative y-axis. We have studied this. Okay. Now, as we have studied this, by using this sign convention, we calculate the summation here. Remember this thing. Summation of forces acting in x direction. Suppose that one force is there. Suppose that such one force is there. Okay. Then we will split this force in two components. One will be parallel to x-axis and one will be perpendicular to x-axis, means in y direction. Okay. So if this is f, then this will be fx and this will be fy. Okay. Means we have splitted this component in x direction. We have splitted this force in y direction. Okay. And we can split this by using the angle theta. Okay. So fx will be f cos theta and fy will be f sin theta. Okay. Now again, suppose that one more force is acting in this direction. Okay. Then we will also split this force into the two components, that is fx and fy. Okay. Suppose that this force is r. Okay. So therefore we will split this rx and Ry. Okay, now what will happen here? Remember this thing. What is going to happen here? From this diagram, your fx will be equal to f cos of theta. F cos of theta. Theta will be the angle. Okay, angle made by your axis. Angle made by your force with the x-axis. This will be your theta. Okay, and this angle will be again your theta. Both angles are different, but you can consider this as theta 1 and this will be your theta 2. Okay, so both angles are also given now. So therefore, from this diagram, you can say that fx will be equal to f cos of theta 1 and fy will be equal to f sin of theta 1. Okay, also rx equal to, r is at the bottom position, r is at this position. Okay, rx will be equal to, now it is in the negative x direction, so therefore minus of r multiplied by cos of theta 2 and ry will be equal to, again this is in negative y direction, so therefore ry will be equal to minus of r sin of theta 2. Okay, so now this is the important concept that you should know. Okay, how we have splitted these forces. Now live I have explained you in front of all of you how we have splitted these forces F and R into the X and Y components, Now what is the meaning of this equilibrium condition? Equilibrium condition means summation of fx will be 0. Summation of fx will be 0 means what? This one is acting in x direction and this one is acting in x direction. So the summation of these two will be equal to 0 if this body is in equilibrium. And summation of Fy will be 0. Fy will be 0 means what? Fy will be 0 means this. These two will be 0. Summation of these two will be 0 if your body is in equilibrium condition. Okay, so remember this thing. Summation of Fy will be equal to 0. And moment at any point is equal to 0 means what? What we have studied here. Here we have studied the moment. Here. Okay, that moment will be 0. Here, the moments are given. Here, these moments are given. Okay, this 1, 2, and 3. These 3 moments are given. Okay, so now I hope that you have understood that these 3 equilibrium conditions. Okay, and these 3 equilibrium conditions can be applied to this beam also. Why we can apply these conditions to the beam? We can apply these equilibrium conditions to the beam because this beam is in also stable condition. You remember this thing. This beam follows the stability. This beam follows the equilibrium. Stable. This beam is in stable condition. So this beam is not moving. If the object is not moving, means it is stable. And if the object is stable, this means that it will follow the equilibrium condition. It will follow the equilibrium condition means what? It will follow the Fx is equal to 0, it will follow the Fy is equal to 0, and it will follow the moment at any point is equal to 0. So this object will follow all these three conditions, and you can apply all these three conditions on this beam. Okay, so let's take this example, how you can calculate the moment. First, you calculate the moment at the point A, which is equal to 10 Newton multiplied by 2 meter. That is 10 into 2, 20 meter. Okay, you can calculate the moment at point A here is equal to first 10 multiplied by 2, which is in clockwise direction. So its sign will be negative. Its sign will be negative, minus of 10 multiplied by 2. Again, next force is 20 Newton. 20 multiplied by 2 plus 2, the distance is 4. Okay, this sign is also in clockwise direction. So that's why it will also have the minus sign, minus 20 multiplied by 4. Okay, third force is 30 Newton multiplied by 8. And it is also having the negative sign, multiplied by 8. Okay, so on your calci, you can calculate this answer, and the answer will be having a unit Newton meter. If you have calculated the answer, you can write in the chat box. Okay, similarly, you can also find the moment at the point B. You can find the moment at the point C, and you can find the moment at the point D. Okay, all these things you can find, and you will get the answer in the same units, that is the Newton meter. Okay, how you can find the moment at the point B? Let's try to calculate it. At the point B, 10 Newton force is acting, which is passing through the point B. So that's why the moment 10 multiplied by 0 will be 0. 10 multiplied by 0 will be 0. Next one is 20 multiplied by distance from the point B is 2. But it is having the clockwise direction. So that's why we will assume the negative sign, multiplied by 2. Again, 30 Newton force multiplied by 6. Minus 30 Newton force multiplied by 6. Okay. So by this way, we are able to find the moment at the point B. Okay. Then moment at the point C and moment at the point D. Okay. Now, let's take this example for your homework. Okay. For your homework, and you try to solve it remaining. You try to solve it remaining. Okay. Let's take this example for your homework, and you try to solve it remaining. Find the moment at point C and moment at the point D. Okay. If you try to solve it, you will definitely get the correct answers, because there is nothing difficult in this numerical. Okay. Now, there is one more thing in this numerical, that is to find the support reactions. Now, what is this support reactions? Remember, what is this support reaction? Support reaction means what? When you consider the Newton's third law, that to every action there is equal and opposite reaction. To every action there is equal and opposite reaction. So there will be a reaction at this end, because you are applying the downward force, so it will exert an upward force. Okay, and that upward force will be the support reaction. So that support reaction you have to find, and that support reaction will be in upward direction, will be in upward direction. So this will be the support reaction. Okay, and how to find that support reaction, that we will continue in our next lecture. So till you try to solve this thing, you try to get the answer for this thing, you try to find what is moment at the point C, and you try to find what is moment at the point D. Okay, so therefore I request all the students to solve this numerical at your home